In this video, I'm going to do two more investigations for a graph. So notice how in the first investigation video, we just had x squared and then opposite of x squared, so opening up versus opening down. And then in the video after that, we talked about adding 2 moves up, but depending on how you add 2, outside of your square part, your square term piece, is up, but inside paired with your x is actually opposite of the movement we thought. So this went left. I thought it was going to go right, but it went left. And so now we're going to investigate a different kind of 2, a multiplier of 2, and I want to show you how that will alter your quadratic picture. And so I'm going to draw the picture first by substituting in my points. I'm going to get my points, and then I will answer these questions on graph 5. So here we go. I'm going to substitute in where I see the x, the number -3. And this is going to be, again, when you are simplifying here, you want to follow the order of operations. So I'm going to write that down here for you. Notice how the exponent must be addressed before we multiply by that 2. So I have to do 2 times 9. So don't be tempted to make -6 here, because that would not be correct math. Okay, so 2 times 9 gets me 18. And then double what I get from -2 squared, or double 4, and we get 8. Double what we get from -1 squared, so double 1. And here, double what we get from 0 squared. Well, anything times 0 is 0. And double 1 squared. And then double 2 squared. And then double 3 squared. Okay, and now what we're going to do is plot these points. -3, 18, -2, 8, -1, 2. So this is my x and this is my y. So -3 up 18. And -2 up 8. And -1 up 2. 0, 0. 1 goes to 2, 2 goes to 8, and 3 goes to 18. So here is my picture now. So it's skinnier than what we had before. Can you see that? It's not terribly skinnier, but it is skinnier. The question here, how does this parabola's appearance change from all the others that we've plotted so far? Well, I said it definitely is skinnier. And what I mean by that is that it rises faster. So it's maybe, we'll call it taller. I'm skinny. And then what happened to the pattern for plotting the points? So notice how I did see that 9, 4, 1, 0, 1, 4, 9 happening, but then we doubled it. And so I want to talk about that over here. So we went double the normal amount. So instead of going where it says when you went right or left, instead of going right 1 squared, we went up 2. And then, actually, I should add this here because this was the 1. This should have gone up here. Sorry about that. So this is answered here, and this is answered here. So I'll just add when we went right 2, instead of going up 4, we doubled 4. Right here we doubled 4, we went up 8. And right 3, instead of going up 9, we doubled it. Instead of going up 9, we doubled it to 18. So it's double the square. So why do you think that is? I think that is because it's 2 times the x squared. And so it's double the x squared values we did before. I'm going to say that we did first. Okay, now, graph 6. I need to have my graph before I can answer my question, so I want to talk about how this is going to change from this. So hopefully if you know what doubling did, I think you might be able to guess what halving will do. And so, right, half is opposite of doubling, so what do you think opposite of skinnier is going to be? Let's check it out. Let's investigate. All right, so what I'm going to do is substitute in for -6 my x value. I'm going to plug -6 in there. I'm getting a little confused with my words. Sorry about that. And then I will solve for y. So I'm going to take half of -6 squared. And remember with PEMDAS, you need to do the exponent before you can multiply half. So I'm going to take half of 36, which is going to be 18, because -6 times -6 is positive 36, and half of that is going to be 18. Half of -4 squared, or half of 16, is going to be 8. Half of 4 is going to be 2. Half of 0 squared, half of 0 is still 0. Half of 2 squared, or half of 4, is 2. I'm noticing they didn't give me any odd numbers like we had done before, and probably because half of 9 is going to be in the middle, or half of 1 is going to be in the middle, like a half, or half of 9 is 4.5. So I'm curious, that's probably why we didn't have odd numbers here. 4 times 4 is 16. Half of 16 is 8. And half of 6 squared, or half of 36, is 18. Okay, so now I'm ready to plot my points. So my points are going to be -6, 18, -4, 8, and so on. So I'm going to start with this one, -6, and I'm going to go up 18. And then -4, 8. -2, 2. 0, 0. And then 2, 2. 4 goes to 8. And 6 goes to 18. It was definitely wider than what we had here. So what I'm going to write down, what did it change? How did this parabola's appearance change? It got wider, or maybe you want to call it fatter. What happened to the pattern for plotting the points? And then here, when we went left or right 2, so from the origin here at 0, 0, we went over 2, up 2. When we went over 4, so from the origin over 4, we went up 8. So right 2, this was a right 4, and 6, we went up, over 6 we went up 18. And each of these are half of the square. Because 2 squared is 4, 2 is half of that, 4 squared is 16, notice 8 is half of that, and 36 is the square of 6, half of that is 18. So we went half of the square because our function was a half times x squared. So why did we only plot even numbers? Well, that's because the even numbers in half are a nice point. But if we went half of 1 squared, half of 1 is not a very nice point. Or half of 3 squared, meaning half of 9, would be 4.5. And so that's why we didn't plot those, because they didn't look so nice. So over 1 up a half, which we actually did with our picture. Over 3 up 4.5, and look, it really does match there. I know now why it looks like that, but plotting a half point is sometimes a little more challenging. Not that you can't do it, but that's why we only graphed even numbers. Nice job.